Hello, for the second problem, I chose to do question number 8 for week 2A, and it states a particle with a charge of negative 4.9 microcoulombs and a mass of 1.1 times 10 to the negative 6 kilograms is released from rest at point A and accelerates towards point B, arriving there with a speed of 57 meters per second. The only force acting on this particle is the electric force. What is the potential difference between VB minus VA between A and B? So first of all, I know that I'm going to be looking for potential difference, and I know that potential difference is electric potential, and that's measured in volts. That's its SI units, and it's just a V. So I know I'm going to be looking for V, and then I'm given a bunch of other information, and I know that I'm given Q, which is the charge. It's the value of point charge, and its SI units are coulombs. So it's given to me microcoulombs, so I went ahead and converted it to coulombs to be able to quickly use it later in my equation. So negative 4.9 microcoulombs converts into negative 4.9 times 10 to the negative 6 coulombs. So that is my Q, and that is the charge that's here at rest. And I know that at rest, its velocity is going to be 0, and then it states that its final velocity when it reaches point B is 57 meters per second. Velocity is a vector that demonstrates how fast an object is moving, and it is measured in meters per second, which is right here. That's its SI units. So next, I was able to determine that I need this equation because I'm given Q and I need to find V. And then from all this information with velocity and everything like that, I can find potential energy because, or I can use potential energy to be able to find my V, my electric potential. So I am able to determine that in this equation it says the potential difference. So I know that eventually I have to do the change in V equals change in potential energy. So change in potential energy is also equal to change in kinetic energy, because I'm able to use kinetic energy for this equation. I use change in kinetic energy equals half mv squared, and then that's v2, which would be the second velocity, minus the initial velocity. And I'm able to cancel out this equation because I know that my initial velocity is equal to 0. So I'm just left with this main equation. And in this equation, I have kinetic energy, and kinetic energy is a change in I put it as change in kinetic energy, is the measure of energy in motion. This is joules. And then potential energy is the change in potential energy, that is measure of energy, joules, stored in an object. And it's both SI units for kinetic and potential is joules. And then I also have in this equation m, which would be mass, and that's a measure of weight, and its SI units are in kilograms, and that's perfect because I'm already given kilograms, so I don't have to convert anything. So I know that my change in kinetic energy would be half, and then my weight or my mass of my object times my final velocity. So it should be a little 2 under here. And then my change in kinetic energy equals 1.787 times 10 to the negative 3 joules. So since I've stated up here that my kinetic energy is equal to my potential energy, or the change in both, I'm able to just plug it into this equation. And in this equation, I get change in velocity equals, not velocity, electric potential is I use change because it says what is the difference between these two volts. So I'm able to determine the voltage difference from these two spots by doing the change in potential energy divided by Q. So then I just do change in potential energy divided by my original charge, and that gives me 365 volts. And this is positive because the volts are going to be positive. You wouldn't have a negative volt